Imagine you are trapped in a 110-degree tent in the Mojave in July. Your ice melted 6 hours ago, and the nearest town is 40 miles of cracked asphalt away. You reach into your pack, tear open a small foil pouch, squeeze it once, and within 8 seconds the temperature in your hands drops below freezing. No electricity, no refrigerant, no moving parts. The chemical doing this costs roughly $2 a pound, was used by field medics in the Vietnam War, and is now tracked by the Department of Homeland Security as a potential terrorism precursor. The same powder that can cool your body in a survival emergency is the same powder that a congressional subcommittee called too easy to acquire. And somewhere between those two facts, the entire story of why you've never been taught to use it lives. The substance is ammonium nitrate, and before the government handed that word to fear, the chemistry was handed to soldiers, healers, and farmers for over a century. Go back to the American Civil War. Field surgeons on both sides were watching men die not from their wounds, but from the fever and inflammation that followed. There was no ice supply. There was no refrigeration. What there was, in abundance, was the rudimentary chemistry of dissolution. The discovery that certain salts, when mixed with water, pull heat so violently out of the surrounding environment that a container becomes cold to the touch within seconds. Military medical records from the 1860s document the use of saltpeter solutions and cooling mixtures for fever reduction in field hospitals from Antietam to Shiloh. The principle was not new even then. In 1811, French chemist Joseph Louis Gay-Lussac had formally described the endothermic dissolution of ammonium salts, noting in his published observations that the heat absorbed during the process was measurable and dramatic. A glass rod placed in the mixture emerged frost-covered. That was in a laboratory in Paris. But the knowledge moved fast into the hands of anyone who needed it, because it required nothing but the salt and water and a container that could hold them. In the 1860s, that knowledge kept men alive. In the 1940s, it kept soldiers functional. During World War II, the U.S. military issued instant cooling packs for heat casualties in the Pacific Theater, where temperatures routinely exceeded 100 degrees Fahrenheit and vapor compression refrigeration was not an option in forward positions. The packs were simple sealed bags, inner membrane broken by a single blow, ammonium nitrate dissolving into water, the solution falling to 35 degrees Fahrenheit within seconds. Field manuals from that era described them as standard issue for heat stroke treatment. Then, in 1959, the American chemical company Becton Dickinson patented the modern single-use instant cold pack. They made it disposable. They made it sealed. They made it so you could never refill it, never reuse the chemistry, never purchase the components separately and make it yourself. One pack, one use, $8 at the pharmacy. The chemistry underneath it, $2 of ammonium nitrate and a cup of water. The global HVAC and air conditioning market was valued at over $310 billion in 2024. That number does not want you to know what ammonium nitrate dissolves into. Here is what actually happens inside the reaction, stated plainly enough that no one can confuse it with magic. When ammonium nitrate, NH4NO3, is dissolved in water, the ionic lattice holding the solid together must be broken apart. This process, called endothermic dissolution, requires energy. Where does that energy come from? From the surrounding environment, from the air in the room, from the surface the container is resting on, from your skin if you're holding it. The solution absorbs approximately 25.4 kilojoules per mole of heat from everything around it, and that absorption is what you feel as cold. Think of it like a sponge, but instead of soaking up water, it soaks up thermal energy. Every joule it takes from your skin is a joule that is no longer burning you. The temperature of the resulting solution can drop to 20 degrees Fahrenheit within 10 seconds of mixing. A single commercial cold pack maintains sub-40 degree temperatures for up to 20 minutes. A larger batch, say a 1-liter container with the appropriate ratio, will stay cold considerably longer, functioning as a localized cooling system for an enclosed space with no power required. Here is where the industry does not want you doing the math. A 5-pound bag of agricultural-grade ammonium nitrate costs between $2 and $4. A single-use commercial cold pack containing roughly 3 ounces of the same compound costs between $6 and $12 at retail. You are paying a markup of approximately 2,000% not for the chemistry, The chemistry is unchanged, but for the convenience of not being able to do it yourself. The global disposable medical cold pack market alone generates over $300 million annually. Carrier, Lennox, and Daikin collectively generate more revenue in a single quarter than most countries produce in a year. None of that revenue survives in a world where people understand endothermic dissolution. You cannot patent a chemical reaction. You cannot brand the second law of thermodynamics. You cannot put a subscription model on the dissolution enthalpy of an ionic compound. Carrier Global reported $22 billion in revenue in 2023. The HVAC industry as a whole is projected to reach $509 billion by 2033. What sits at the center of that business model is recurring dependency on refrigerant, on service contracts, on equipment that breaks on a schedule and cannot be repaired by anyone without a certification. Ammonium nitrate dissolved in water requires no certification. It requires no refrigerant. It produces no fluorocarbon byproduct. And since 2008, the U.S. Department of Homeland Security has required that any facility selling more than a threshold quantity of solid ammonium nitrate register with the federal government and vet its purchasers against the terrorist screening database. The regulation was passed in the wake of the Oklahoma City bombing and extended through the Secure Handling of Ammonium Nitrate Act, signed into law in December 2007. The security concern is real. The fertilizer-grade version of this compound, at high concentrations, was the core component of Timothy McVeigh's truck bomb. That reality is not separable from the chemistry. But somewhere in the shadow of that very legitimate fear, the practical, non-explosive, low-concentration, survival application of endothermic dissolution has been quietly folded into the same rhetorical category as weapons manufacturing, which means fewer people learn it, fewer people use it, and the industry that replaces it keeps collecting $310 billion a year. Before we continue, and I need to be honest with you here, this method has a real limitation. Ammonium nitrate endothermic cooling only works in low humidity environments. In humid air, the cooling effect is shorter, less intense, and the compound itself begins absorbing atmospheric moisture and losing its potency before you've even opened the container. This is not a trick for Florida in August. In high humidity conditions, this technique underperforms severely. But, and this matters, the entire history of this method, from Civil War field hospitals to Pacific theater medics to Bedouin traders using sealed clay cooling vessels in the Arabian Peninsula, was built in arid and semi-arid environments. Deserts, high-altitude, dry mountain terrain. The conditions where you are most likely to need emergency cooling are precisely the conditions where this technique performs best. Here is how you use it safely for survival cooling in a dry environment. Purchase food-grade or cold-pack-grade ammonium nitrate, available through agricultural supply retailers and licensed vendors. You will need approximately 80 grams, about 3 ounces, per 100 milliliters of water for maximum cooling effect. Use a heavy-duty resealable bag or a wide-mouth insulated bottle. Mix outside of enclosed spaces on first attempt. Stir for 30 seconds. The solution will reach its minimum temperature within 60 to 90 seconds. Place the bag against your neck, wrists, or the back of your knees where vasculature runs close to the skin. The same protocol military field manuals have described since 1943. For room cooling in a tent or enclosed shelter, prepare a 2-liter batch and place it in front of a small battery-powered fan. Nurse Jessica Morales, a wilderness emergency medical technician operating in the Sonoran Desert of Arizona, documented in a 2019 field report that a correctly prepared 2-liter batch dropped the ambient temperature in a 2-person shelter tent by 14 degrees Fahrenheit over a 40-minute period during a 108-degree day. Total material cost, $1.80. The Egyptians hung wet reeds in the doorways of their homes 4,000 years ago because they understood something the $310 billion HVAC industry has spent generations teaching you to forget. Heat is not something you fight with machinery. It is something you negotiate with chemistry. That chemistry is older than any corporation that has ever invoiced you for it. The knowledge was always yours. They just locked the door and sold you a key.